Good morning, guys. I just wanted to really quickly review the problems we had yesterday and how to do fractions as division problems. And the two big important points about this is that one, um, every fraction is a division problem, and two, the numerator, the number on top, is the thing that we are sharing or dividing, and the denominator is are the people or the things that are getting the items that are being shared. Okay? So look at number one. Which statements are true about 4/7? Now we know that 4/7, because the fraction is actually a division problem, and it's the same as 4 divided by 7. So which one of these is going to be true? Well, 4/7 is the same as 4 divided by 7. True. A. My pen's not working. B. 4/7 is the same as 7 divided by 4. That is not true. We're going to leave that. C. 4/7 is the same as 4 times 1/7. Well, when you multiply 4 times 1/7, you multiply the numerators and you multiply the denominators and you get 4/7. So C is also true. D. 4/7 is the same as 7 times 1/4. No, because 7 times 1 is 7 and 1 times 4 is 4, and that is not the same. So the answers are A and C. Okay. Adia has a 20-foot length of wire. She cuts it into 6 pieces of equal length. The length of each piece of wire will fall between which two whole number lengths? Okay, so here is Adia's wire. It's 20 feet. Okay, and I said earlier that the numerator in a fraction is the thing that is being shared or divided. So what's being divided here? The 20-foot wire or 6 pieces? Well, we can't divide pieces. Doesn't make any sense. We're dividing the wire. So the numerator is going to be 20 feet. And what the item that we're dividing, excuse me, the denominator is going to be 6, because that's what we are, that's the number of pieces we're dividing it into equally. Okay? And I'll just draw 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's pretend that's equal. All right. So it's 20 feet of wire divided into 6 equal pieces. Okay? So we want to know between what two number whole lengths. So that means we're going to turn this improper fraction into a mixed number. So 6 goes into 20 how many times? Well, let's count by 6's. 6, 12, 18, 24. Oh, 24 is too high. So we're going to go back to 18. So 6 times 3 is 18. So that's going to be the whole number. And how many more do we have to count up to get to 20? So we have 18. There's 19, 20. So that is 2 more. So that's our numerator. And our denominator is 6. Okay? And if we simplify that, we keep our whole number the same. And then we're going to take 2 6s and say, what number goes into both 2 and 6? What can we divide 2 and 6 by equally by the same number? And we know that that number is 2 because we're all amazing mathematicians. So 2 divided by 2 is 1. 6 divided by 2 is 3. So it's 3 1/3. So between what two whole numbers is 3 1/3? Well, we know, take a number line. We know that 3 1/3 is obviously bigger than 3 because we have 3 as a whole number. And it's a little bit bigger because it's 1/3 bigger. So it's going to be bigger than 3. So I'm going to put like a dot here. It's going to be bigger than 3. But it doesn't get to 4 yet because the whole number is not 4. So we know it's going to be between 3 and 4. Okay, Dominic is preparing chicken salad for 4 friends and himself. He makes 14 cups of chicken salad. Which expressions represent the amount of chicken salad each person gets if they share the chicken salad equally? So, this is a tricky question because it says Dominic is preparing chicken salad for 4 of his friends and himself. So, how many people are eating? Well, there's 4 friends plus Dominic. So, it's going to be 5 people. So, tricky, tricky. It seems like because we see the number 4, we want to pick the number 4. But it's Dominic and his 4 friends. So, it's 5. And what are they sharing? They're sharing chicken salad. So, are they going to share the people or are they going to share the chicken salad? Okay, we don't share people because yuck, that's gross. We're going to share the chicken salad. So, there are 14 cups of chicken salad. And we're going to divide it by 5 friends because it's Dominic plus his 5 friends. Okay, so we have 14 divided by 5, which is the same as what fraction? That would be 14 over 5. Let's see which of these options work out for that. 14 divided by 4? No. Well, this is interesting. It's a mixed number. Let's check to see if 14 fifths makes this mixed number. So, 5 goes into 14. Let's count. 5, 10, 15. Whoops, 15's too big. Let's go back. 10. So 5 goes into 14 2 times with 4 left over. 2 and 4 fifths. Look, yes, it matches. Option 2. All right, option 3, 14 fifths. Yep, we already said that was one of the ones. 14 times 1 fifth. Now is 14 times 1 fifth the same as 14 fifths? Absolutely. 14 times 1 is 14. Oops, that's a funny 14. And then we know there's an invisible 1 underneath. 1 times 5 is 5. So this one works too. And then our old reliable division equation, 14 divided by 5. So all of them work except for number 1 because we don't have it's not just 4 friends. Dominic made the food and he's hungry too. Okay. Avery has 7 bags of soil. She puts an equal amount of soil in 4 outdoor planters. Oh, not Avery, it's Andrea. Oh, I named this one after myself. Okay, so are we going to be sharing or dividing the potting soil or the planters? Well, we went over this in the video yesterday, and I was pretty clear that it really should be the potting soil because you've got to imagine we have a bag of dirt and we're dividing it into the 4 pots for the plants. So that's going to be the 7 bags of potting soil, and we're going to put an equal amount into 4 planters. Okay? So the answer is 7/4. All right. What else? Oops. There's a lot of questions. I don't want to go over all of them because it gets a little bit repetitive. And some of you that have my class will recognize some of these too because you actually took a quiz with these exact same questions before we left school. And this is one of them that people found to be very difficult. So pay attention because it has a model and it has 2 parts to the question. Okay? The model shows how Michael is dividing some pounds of peaches to make 3 pies. Okay? From the model, you can see that Michael is dividing blank pounds of peaches to make blank pies. Okay, this is how you do this. You count how many pounds we are using here. Okay, so how many pounds? It says 1 pound, 1 pound, 1 pound, 1 pound, 1 pound, 1 pound, 1 pound. So how many of those? 1, 2, 3, 4, 5, 6, 7. So 7 pounds of peaches to make how many pies? Okay, what are we dividing each pound into? How many parts? Each pound is divided into 1, 2, 3. Okay, so we are using 7 pounds of peaches to make 3 pies. So the answer is the first one. Okay, moving on. This means that he will use blank divided by blank equals blank pounds in each pie. So if you got 7 and 3 earlier, it's going to be very easy to say that you're going to use the 7 pounds of peaches divided by 3 to get 7/3 pounds in each pie. Remember, when you're making a pie, you cut up all the fruit, and you cut up all the fruit and you divide it into each pie. You don't first bake a pie and then cut up the crusts and then line up all your peaches and put the little pieces of crust for each peach. No, you cut up all your fruit and then you take your 3 pie pans and you divide the fruit into each pan. I hope this was helpful, and I hope you do great today on your assessments. Good luck and have a great morning and afternoon.